Hello everybody, and welcome back to another lesson on solving trigonometric equations. I believe this is notes number 48. So we're going to start off where we left off last time, which was in solving a trigonometric equation that is a quadratic in disguise. So let's write this one down. 2 cosine squared theta plus 3 cosine theta equals 2. So if we're going to solve it by factoring, we need to get everything over to one side. So we have 2 cosine squared theta plus 3 cosine theta minus 2 equals 0. Now let's see if we can factor it. So we get 2 cosine theta times cosine theta. We get a 1 and a 2. And we get, let's see, what would it be? A minus 1 and a plus 2. That makes everything work out. So now we're going to set each factor equal to 0. So we have 2 cosine theta minus 1 equals 0. I'm having some technical difficulties, so I apologize. I have to go a little bit slower, and some things aren't coming out as clear. Okay, so now we're going to solve each equation. So we're going to start with the first equation and add 1 to both sides, and then divide by 2. Okay, so now we're going to take the inverse cosine, and we get theta equals inverse cosine of 1/2. Remember, that means the angle whose cosine is 1/2. And don't forget that our instructions are to get all of the solutions that are on the interval from 0 to 2 pi. So we will have multiple solutions because there are multiple quadrants that give us a positive cosine value. We get a positive cosine value in quadrant 1. So we would have a 1 and a 2 for adjacent and hypotenuse. So the opposite side would be square root 3. So we know this is a 60-degree angle. And then cosine is also positive in quadrant 4. So we're going to have a 60-degree angle down there as well. So 60 degrees is pi over 3 radians. So our answers for this part of the problem are pi over 3 radians, and for quadrant 4 it would be 300 degrees, and so it would be 5 pi over 3 radians. So we have 2 of our answers. Now let's work on the other equation. So we have cosine theta plus 2 equals 0. Subtract 2 from both sides, and we have cosine theta equals -2. Okay, at this point, you might realize that this has no solutions, because if you think about a cosine graph, how high does it go and how low does it go? Okay, it goes up to a height of 1 and down to a height of -1. It doesn't go to -2. But if you don't realize it at this point, what you can do is take the inverse cosine of -2. Okay, that would mean you had something in quadrant 2 or quadrant 3 because of the negative, and you could put a -2 on the adjacent and a 1 on the hypotenuse. And at this point, hopefully you realize that this is not possible, so we don't get any solutions from that. But we do still have the other 2 solutions to the problem that we got from the first part. Okay, let's move on to equation number 2. All right, what we're going to look at with this example and the next one is quadratics in disguise that are not factorable. Oh no, not factorable. We should just quit. Oh, don't forget, we have the quadratic formula. We also have completing the square, but let's just use the quadratic formula. So this one is not factorable. So when using the quadratic formula, normally you're solving for x, but in this case we're solving for tan theta. And the coefficients a, b, and c are a is 1, b is 4, and c is 2. So we'll put those into the quadratic formula. We have the opposite of b, -4 over 2a, 2, plus or minus the square root of b squared, 16, minus 4ac, minus 4 times 1 times 2, over a squared, 2. Now we simplify. So we have -2 plus or minus the square root of 8 over 2. And I'm not going to take the time to do every single tiny step, but you know that square root 8 is 2 square root 2, and that's going to reduce with the 2 on the bottom. So we have negative 2 plus or minus square root 2. And that is equal to tangent theta. So we actually have two numbers there. We have the one with the plus and the one with the minus. So let's break this down and let's take the inverse tangent. So we have theta is inverse tangent of negative 2 plus square root 2. And we have theta is inverse tangent of negative 2 minus square root 2. Well, I don't know about you, but I do not know an angle who has a tangent value like this. This is not a familiar one. This is not a 30, 60, 90, 45, nothing like that. So we're not going to be able to find an exact answer. What we're going to do is find approximate answers with our calculators. So grab your calculator, make sure it's in radian mode. Go to mode, make sure it's in radians, not degrees. And then just type in this whole thing. And you're going to get approximately, that was a fancy theta I just made. You're going to get approximately negative 0.53 radians. Okay, now there's a little bit of work we need to do with this, because remember the problem said give your answer between 0 and 2 pi. Negative 0.53 is not between 0 and 2 pi. Let's figure out where this is. So we're talking about quadrant 4. We went 0.53 radians clockwise. Okay, so what would that be if we were to rewrite it using a number that fell between 0 and 2 pi? What we would have to do is go all the way around the circle one more time. That would be adding 2 pi to this answer. So we have negative 0.53 radians plus 2 pi radians, and that's going to be 5.75 radians. That's a quadrant 4 answer. Keep in mind, there's another quadrant with a negative tangent value. Which quadrant has a negative tangent value other than quadrant 4? Let me hear you say it. You're right, it's quadrant 2. So if you were in quadrant 2, you would have the same size reference triangle. So that means it would be half a circle away, right? Between quadrant 2 and quadrant 4, if you're doing a tangent ratio, you're half a circle away from the other one. And half a circle is how many radians? That's right, it's pi radians. So your quadrant 2 answer is going to be negative 0.53 radians plus pi. That's just half a circle away. And that gives us approximately 2.61 radians. And that's another answer, and that's our quadrant 2 answer. Okay, now remember we had the other answer over here we still need to work through. So that goes in the calculator as well, and we get approximately negative 1.29 radians. Now, the same idea applies. It's a quadrant 4 angle. So this angle was negative 1.29, or since we're going clockwise, we'll call it just 1.29 going clockwise. Okay. So again, we need to make that some number that's in the same position, so something coterminal that falls between 0 and 2 pi. So we're going to add 2 pi to that. And we get another approximate answer of 1.85 radians, which doesn't quite sound right, so let me check on that. Okay, this one is 4.99 radians. So that's one of our answers, and that is a quadrant 4 answer. And just like we saw in the previous part of the problem, there's also going to be a quadrant 2 answer. So we're going to take our 1.29 radians and add pi to it, and that's going to take us to the one that's over there in quadrant 2. That is 180 degrees, or half a circle. pi radians away from the one we just got. So when we add pi to our answer, we end up with 1.85 radians. So this problem has 4 approximate answers. 2 answers from quadrant 2 and 2 answers from quadrant 4. Okay. Let's try something like that again. We probably need a little bit more practice. And if it's not tangent, but it's sine or cosine, finding those extra answers requires a little bit different thinking. Okay, so moving on to number 3. It's another quadratic in disguise. And we're going to get everything over to one side and see if it's factorable. So we have 9 sine squared theta minus 6 sine theta minus 1 equals 0. Okay, it is not factorable. Boo-hoo-hoo. We're going to use a quadratic formula. So we're solving for sine theta. And our value of A is 9, and our B is -6, and our C is -1. So sine theta is the opposite of B, positive 6, over 2A, 18, plus or minus the square root of B squared, 36, minus 4AC, so minus 4 times 9 times -1, over 18. And that gives us 6/18, plus or minus the square root of 72 over 18. Okay, you're going to simplify 6/18, that's 1/3. And you're going to simplify 7 square root 2, or excuse me, square root 72. That would be 6 square root 2, and it reduces with the 18, and you end up with square root 2 over 3. Just to speed things up a little bit, I didn't write all those steps. So those are the values of sine theta. We want to know theta. So let's split that up into 2 equations. Theta would be the inverse sine of 1/3 plus square root 2 over 3 to 2. Or theta would be the inverse sine, forgot my inverse on there, the inverse sine of 1/3 minus square root 2 over 3. Okay, guess what we're going to do? That is correct. We're going to grab a calculator, make sure it's in radians, and we're going to type these in and see what we get. So for the first one, we get approximately 0.94 radians. Now that would be in quadrant 1. Okay, 0.94. Well, sine is also positive in quadrant 2, so you're going to have a quadrant 2 answer. Notice that these are not 180 degrees apart like they were for tangent. These are not just on the opposite side of the circle. And so we're not going to be able to just add pi to get the next answer. So we have to think it through geometrically. So if one triangle has a reference angle of 0.94 radians, then the other triangle also has a reference angle of 0.94 radians. So then how far did we go to get to the terminal side? We went not half a circle, we went half a circle minus 0.94. So go the half circle and then come back 0.94. So that would be pi minus 0.94 radians. And this is approximate as well. And pi minus 0.94 radians is 2.20 radians approximately. So we have a quadrant 1 answer, 0.94 radians, and we have a quadrant 2 answer, 2.20 radians. Those are both approximate. Okay, now we go through the process with the other value, the inverse sine of 1/3 minus square root 2 over 3. Put that in the calculator, and we get approximately negative 0.14 radians. That's going to be in quadrant 4. So that would be 0.14 radians going clockwise. So first of all, we have to give an answer that falls between 0 and 2 pi. So just like we did with the last problem, we're going to add 2 pi radians to that to get it back between 0 and 2 pi, and it would be coterminal with this answer. So when we add 2 pi to negative 0.14, we get 6.14. And that's our quadrant 4 answer. And now, where else is sign negative? Sign's negative in quadrant 3. So we're going to have a quadrant 3 answer. And if we went 0.14 radians for one reference triangle, then we're going to go 0.14 radians for the other reference triangle. So that means we go half a circle plus 0.14. So we go pi plus 0.14. So you have to picture it. It's not just a formula to add or subtract something. You have to picture what's going on for each different case. And pi plus 0.14 is approximately 3.28. So 3.28 radians gives us a quadrant 3 answer. Okay, so those are the trickiest ones of our assignment today. We still have a couple more examples to take a look at. Let's move on. Number 4. Okay, this is a different kind of example because you'll notice that there is cosine squared in it and sine squared in it. So it's not just a typical quadratic equation because it has two different kinds of functions in it. So here's the strategy for this problem and for the next problem. Use trigonometric identities to do a substitution. What we want to do in the process of doing a substitution is eliminate one of the trig functions and just leave the problem with one trig function. So do you remember the trig identity that involves cosine squared theta and sine squared theta? Good, I'm glad you do. It's the Pythagorean identity. It's the one that says cosine squared theta plus sine squared theta equals 1. You can say sine squared theta plus cosine squared theta. It doesn't matter what order you say those in or write them in. So here's what we want to do. We want to either replace cosine squared theta with something else that involves sine squared theta, or we want to replace sine squared theta with something else that involves cosine squared theta. It doesn't matter which one you do, just do one and it will work. So what if I take my identity and I isolate cosine squared theta? Cosine squared theta equals 1 minus sine squared theta. And so I take 1 minus sine squared theta and I substitute it in my equation where I have the cosine squared theta. So here's what we have now. We have 1 minus sine squared theta equals sine squared theta plus 1. Okay? So we met the goal of changing everything into sine squared thetas. Now we can keep simplifying and solve this equation. So let's subtract 1 from both sides. And we have negative sine squared theta equals positive sine squared theta. Let's subtract sine squared theta from both sides, and we have negative 2 sine squared theta equals 0. Divide by negative 2, and we have sine squared theta equals 0. Square root both sides, and we have sine theta equals 0. Now take the inverse sine. Theta is the inverse sine of 0. So what are the angles whose sine is 0? You might even be able to do it without drawing a picture by this point. Sine is 0 at 0 radians and at pi radians, 180 degrees. So the answers are 0 and pi. Now, if you had decided to use a different substitution and you said sine squared theta equals 1 minus cosine squared theta, and so you substituted 1 minus cosine squared theta into your original equation and solved the whole thing with cosines instead of sines, eventually you would still get the exact same answers. Okay, let's take a look at number 5. So the same idea here. What we want to do is notice that we have multiple trig functions. We have a secant squared theta function and we have a tangent squared theta function. So we have to think about the relationship between those and how we can substitute. So what identity do you know? It's another one of the Pythagorean identities. Remember, 1 plus tangent squared theta equals sine squared theta. Not sine, secant squared theta, excuse me. Okay. And it doesn't matter if you say tangent squared theta plus 1 or if you say 1 plus tangent squared theta. It's the same thing. So let's replace secant squared theta in our equation with 1 plus tangent squared theta. So that gives us 1 plus tangent squared theta equals 2 tangent squared theta plus 4. Okay, let's get everything over to one side. So I'm going to get everything over to the right. So I'm going to subtract tangent squared theta from both sides. And okay, I just paused for a moment because I realized that this is not exactly the problem I meant for us to do. Apparently I typed the problem in wrong, but we're just going to roll with it because this one is actually even easier than the one that we're supposed to do. Don't tell anybody. Okay, so let's keep going. We're subtracting 1 from both sides, so we have plus 3. Okay, so let's see what can we do here. Let's subtract 3 from both sides. Negative 3 equals tangent squared theta. And then square root both sides, and look what happens. We get the square root of negative 3. Well, that's imaginary, so this is not going to have any solutions. Okay, well, that's probably not as helpful as it was supposed to be if I had done the actual problem. So let me show you what it was supposed to be. Secant squared theta equals 2 tangent theta plus 4. So I'm still going to replace secant squared theta with 1 plus tangent squared theta. And then I'm still going to get everything over to one side because this is a quadratic equation in disguise. So we have tangent squared theta minus 2 tangent theta minus 3 equals 0. Okay, is this factorable? Cross your fingers, everybody. I think it is. Tangent theta minus 3 times tangent theta plus 1 equals 0. Okay, set each factor equal to 0. Tangent theta equals 3, or sorry, minus 3 equals 0. Getting ahead of myself. And then we have tangent theta plus 1 equals 0. Now let's solve each one. So the first one, tangent theta equals 3. This is not an exact value we're familiar with. We know like square root 3 or square root 3 over 3, but not just plain old 3. So this is one we're going to do with the calculator, and we'll approximate it. Let's go ahead and finish the other one. We'll subtract 1 from both sides. Tangent theta equals negative 1. And we'll take the inverse tangent. And this is one we can do. We do know the angles that have a tangent of negative 1. If you think about your 45, 45, 90s in quadrant 2 and quadrant 4. Negative 1, 1, square root 2, 1, negative 1, square root 2. So in quadrant 2, that would be 3 pi over 4 radians. And in quadrant 4, that would be 11 pi over 4. Nope, 7 pi over 4. 7 pi over 4 radians. So we got that half of the problem done. Now we just need to go back to the other one. So we grab the calculator, we do inverse tangent of 3, we get approximately 1.25 radians, and that is in quadrant 1. Where else is tangent positive? We have quadrant 1, we have quadrant 3. And how far apart are those angles? That's right, they're half a circle apart, pi radians apart. So to get the other answer, you want to add pi to this answer. So we have 1.25 plus pi, which works out to be approximately 4.39 radians. And that's going to be your quadrant 3 answer. So this problem has 4 answers. 2 of the answers were exact answers, and 2 of the answers were approximate answers. By the way, did you guys know that 3.14% of sailors are pirates? Think about that for a moment. Wow, if you made it to the end of this video, congratulations. This was a long one. Assignment. I forgot to change my slide. Let's change this to worksheet 2. Solving trig equations worksheet 2. Check answers, ask questions, send pictures, have fun. Thanks everyone.